Hello guys, welcome everyone. Hope you're all doing well. And this is Nithin from third year CSC. I'm here today to present a PPT on solar photovoltaic system with its applications. So without wasting any time, let's get started. So first of all, we need to look what is energy before getting into the solar energy. So energy, as the most important concern of the present and future, has to be discussed, studied, reviewed, and researched in detail. Day by day, there is a depletion of energy resources that are non-renewable and also causing imbalance in nature. This calls for the need of renewable resources of energy which are also clean and harmless to the environment. Presently, the world energy consumption is 10 terawatts per year, and by 2050 it is projected to be about 30 terawatts. So with the increasing energy demands, there comes nature to serve its purpose for clean and sustainable environment. So as the demand increases, so we need to look for the energy sources that are both sustainable and renewable, as well as good for the nature. So solar energy is one of a kind. So solar energy as a renewable resource, solar energy is available in abundance anywhere and everywhere from morning till evening, which gives enough time space for us to harness the energy from the sun. PV does not cause any harmful impact on the nature. By replacing fossil fuels, it reduces air pollution, which in turn reduces acid rain, soil damage, human respiratory alignments. So, solar power can be harnessed even from rooftop. Unlike traditional conventional power systems, it does not need any transmission grid particularly. It can be harnessed at the point of generation directly. So solar photovoltaic system. So this is the system which converts the solar energy into electrical energy. So a photovoltaic cell is a solar cell that is completely dependent on incident light and its intensity. A solar cell or a photovoltaic cell, basically PV cell, directly converts incident light energy into electricity. PV cell can produce from few kilowatts to huge megawatts of energy. Hence, its huge area of applications than conventional energy systems. So there are many types of PV cells, photovoltaic cells. So photovoltaic cell can be manufactured in a variety of ways and from many different materials. The most common material for commercial solar cell construction is silica, basically Si. So but others include gallium arsenide, cadmium telluride, and copper indium gallium selenide. Solar cells can be constructed from brittle crystalline structures or as flexible thin film cells, Si, CDTE, CIGS. So crystalline solar cells can be further classified into two categories, monocrystalline and polycrystalline. As the name suggests, monocrystalline PV cells are comprised of a uniform or single crystals, that is, whereas polycrystalline cells contain different or varied crystal structures. Solar cells can also be classified by their number of layers or PN junctions. Most commercial PV cells are only single junction, but multi-junction PV cells have also been developed which provide higher efficiencies at a greater cost. So the photovoltaic effect, what happens when the light incident on the photovoltaic cells that in turn leads to conversion of electricity. So the photovoltaic effect is a process that generates voltage or electric current in a photovoltaic cell when it is exposed to sunlight. These solar cells are composed of two different types of semiconductors, a p-type and an n-type, that are joined together to create a p-n junction. By joining these two types of semiconductors, an electric field is formed in the region of the junction as electrons move to the positive p side and holes move to the negative n side. This field causes negatively charged particles to move in one direction and positively charged particles in the other direction. Light is composed of photons, which are simply small bundles of electromagnetic radiation or energy. When light of a suitable wavelength is incident on these cells, energy from photon is transferred to an electron of the semiconducting material, causing it to jump to a higher energy state known as the conduction band. In their excited state, in the conduction band, these electrons are free to move through the material, and it is this motion of electron that creates an electric current in the cell. So this is the whole process that takes place inside a photovoltaic cell that in turn leads to the generation of electric current. So there are many applications of photovoltaic system. They are water pumping, lighting, solar cooking, heating, traffic signals, cold storage, and solar PV system in space. So firstly, water pumping. The solar power is commonly used for water pumping facility which has been provided more effective in village for agriculture purposes. The energy from the solar panel is used to operate the pump that is used to lift the water from lower level to a higher level. There is a figure indicating solar water pumping system, so you can have a look for your reference. So then the second is lighting. So basically we have been observed in the roads that there are some lights that have been activated by solar cells or solar panels that is connected to the LEDs. So solar photovoltaic lighting system can be used for street lights and rural areas. Small size panels can easily harness enough energy to glow a street light and LEDs. So after lighting, then comes solar cooking. Solar cookers, the normal cooking will happen by generating heat through burning woods or LPG, gas cylinders, etc. But solar cooking is another way of making cooking through solar energy. So solar cookers are the most happening in the present market. Solar cookers are commercially available and are easy to operate and maintain. The world's largest solar kitchen has been set up in India at Taleti near Mount Abu, situated at a height of 1219 meters above sea level in Rajasthan. It boasts of a 6-module solar steam cooking system and a total of 84 parabolic dish concentrators shell-type receivers. So there is a figure of solar cooker that has been provided in the right hand side of the slide for your reference. You can have a look at it. So then comes heating. So basically we have the water heaters that have been running through electricity, but there are certain water heaters that have been running through solar energy. So the solar energy has been utilized in the field of water heating. So solar water heaters and air heaters have been very common since decades, even before PV cells could exist. Solar water heaters alone help reduce the consumption of energy to a major extent. These trap the heat energy from the sun and store water in the containers. So then comes solar PV system in space. So we are using solar energy for every field in Earth, and even we are using it in space as well. So the solar arrays arranged in the space station produce more than required power for the space station. When the station is in sunlight, about 60% of the electricity that the solar arrays generate is used to charge the station's batteries. Solar panels on spacecraft supply power for two main uses. Firstly, power to run the sensors, active heating, cooling, and telemetry. Then power for spacecraft propulsion, electric propulsion, sometimes called solar electric propulsion. Solar panels used in space are not as same as the ones used in terrestrial applications. They do not require any glass lamination to prevent from moisture. So there will be some differences that have been used in Earth and space. The solar panels aren't the same. There will be some uniqueness in the solar panels that have been used in the space. So at last, energy is precious, so hence use it cautiously. And thank you. This is Nithin and I'm signing off, and have a great day.